Hello there, Mr. Sutton here, bringing you the AB Calculus 6-7 Extra Practice number 1 solutions on total distance. On this problem, we have a particle moving on a straight line for 6 seconds with its velocity shown in the graph above. So we want to figure out the total distance this particle goes over this 0 to 6 interval. So since I'm already given the graph of velocity, we can kind of see what's happening with the direction this particle is going. It starts by going forward, so whatever direction forward is for this particle, and then it stops for a while and then starts going backwards. But all of these steps are going to count towards our total distance. And to add them all up, we're just going to take the area under the curve of velocity. So that's going to be a positive trapezoidal area right here. This is 2 plus 3 over 2 times a height of 2 for that trapezoid. And we're also going to have to add this area down here. And we're going to make sure it's positive because, again, this is total distance. So this is going to be 2 plus 1 over 2 with a height of 1. So 2's cancel here. We've got 5 plus this is going to be essentially 1.5. So that's a total of 6.5. Choice D. For this problem, we're given a table with the velocity of some truck at different times. And we want to use a trapezoidal rule with 3 subintervals to find the approximate distance the truck travels from time 0 to time 3. So we essentially want the integral of velocity from 0 to 3. And that's going to be approximately equal to the following. Since we don't have the exact function for v, we have to use our trapezoidal rule here. So we're going to have 20 plus 60 over 2 times a height of 0.5. Next trapezoid, we've got 60 plus 40 over 2, height of 1.5. And finally, 40 plus 30 over 2 times a height of 1. Now, this would be good enough if it were a free response problem, but it's multiple choice, so we actually need to simplify these. So let's see here. We've got, this is 80 over 2 is 40, and half of that is 20. Next up, this is going to be 50 times 1.5, which is 75. And finally, this is just 70 over 2, which is 35. So we've got 95 plus another 35 comes out to 130 miles, which gives us choice B. For this problem, we have a point moving on a straight line with a distance given by this 8t minus 3t squared formula. Based off of that, we want to find the total distance covered by the point from 1 to 2. Now keep in mind this formula is only our distance from some fixed point, not necessarily the total distance covered overall. Alright, so to do this, we need to figure out, first of all, since we're talking about total distance, whether our particle keeps going the same direction the whole time, or whether there's a direction change at some point on the interval from 1 to 2. To figure that out, we need the velocity. So that's going to be 8 minus 6t. And now I need to set this equal to 0 and solve it to see if there's any critical values, possible turnaround points, on the interval from 1 to 2. So setting this equal to 0, I can actually factor out a 2 just to make my life a little easier. So that's 4 minus 3t equals 0. And then, let's see, subtract 4, divide by negative 3. That's a critical value of 4/3. Now, this is the only critical value, but it is between 1 and 2. So we are going to have to do a little sign analysis to see if we change directions. So let's see here. Plugging in a number less than 4/3, like 0, that's going to make this stuff come out positive. Plugging in something bigger than 4/3, like 2, that's going to make this stuff come out negative. 4 minus 6 is negative. So we do have a direction change, and we're going to have to figure out the distance traveled between 1 and 4/3, and add that to the distance traveled between 4/3 and 2, and we have to make sure that all the negative stuff becomes positive when we're adding up these distances. All right, so let me figure out where I am in terms of position at time 1. So that's going to be 8 times 1 minus 3 times 1 squared. That's essentially 8 minus 3, or 5. Now at 4/3, where am I? So I'm going to be at, let's see, whatever all this stuff is when I plug 4/3 into it. So we've got 32 over 3. And then for this one, let's see here, this is 16 over 9 times 3 is 48 over 9 that I'm subtracting. Well, we could turn this into a common denominator. Let's see here. Actually, I can reduce this by 3's. This is actually 16 over 3. 32 over 3 minus 16 over 3 is also 16 over 3. So there's our position at time 4/3. And now at time 2, let's see what we have here. This is going to be 16 minus 12, so that's going to be 4. All right, so I need the distance between 5 and 16 thirds. 16 thirds is a little bigger, so I'll do 16 thirds minus 5. And I'm going to add to that the distance between 16 thirds and 4. And 16 thirds is also a little bit bigger than 4, so we'll subtract in that direction for that pair of numbers as well. So I've got, let's see, 16 thirds minus 15 thirds is 1/3. Over here I have 16 thirds minus 12 thirds. That's 4 thirds. So I've got 1/3 plus 4 thirds is 5 thirds. And that is choice C. For this problem, we have a particle moving on the x-axis, and the velocity is given by v of t, acceleration by a of t. We want to know which expression here gives us the average velocity of our particle from time 0 to 8. So average value, that's going to be 1 over the interval length, so 1 over 8 minus 0, times the integral from 0 to 8 of, what are we averaging? Oh, velocity. So we're going to put velocity in here, vt dt. So that's going to be answer choice B out of all of these. Now just looking at some of the runners up here, choice A, this was the average rate of change of acceleration, so that doesn't really help us. Choice C was kind of close, but this is the average speed since we have the absolute value in there. And choices D and E were just complete nonsense, so B it is. For this problem, we're given the velocity of a particle with this function here. We want to know how many meters our particle traveled from time 0 to 4. Well, first thing we need to figure out is if there are any direction changes for our particle, because if there are, then the displacement and the total distance will not be the same thing. Now looking at our function here, if we look at just the t-values from 0 and greater, this is actually going to come out positive for anything greater than 0 as an input. The only way to get negatives out of this thing is if you plug in negatives, and those wouldn't actually work because you're trying to square root a negative. So that means there's no direction changes. And we can just go on our merry way and find the integral from 0 to 4 of v of t dt. All right, so this is a no calculator question. We're going to have to do this by hand. So let's find our antiderivative. For this first one, this bumps up to an exponent of 3/2. Multiplying by 2/3, we end up with, let's see here, 2t to the 3/2. And then for this next one, the new exponent's going to be 5/2. Multiplying by 2/5, we end up with 2t to the 5/2. All evaluated from 0 to 4. So if I plug in 4, just to rewrite this in a form that's easier to work with, this is taking a square root and then cubing it. So I have 2 times the square root of 4 cubed. And same thing over here, but instead of cubing, we're raising to the 5th power. And then we have all of this stuff with 0 also plugged in. Now the good news is this stuff with 0 just comes out to 0, so we don't have to worry about it. For this first set, though, we need to actually simplify it to get one of our answer choices. So we've got the square root of 4, which is 2. Cube that, you have 8, and then 8 times 2 is 16. So we're following PEMDAS here. Next, we have 2 to the 5th is 32, times 2 is 64. 16 plus 64 comes out to 80, choice D. On this problem, we have a bug crawling up a vertical wire at time 0, and the velocity of the bug is given by this graph here from time 0 to 8. We just want the total distance the bug traveled from 0 to 8. Since I'm doing total distance, I have to account for direction changes in my velocity graph. The only place we change directions is here at 6, at least on the interval from 0 to 8. So I'm going to need the absolute value of the integral from 0 to 6 of vt dt, plus the absolute value of the integral from 6 to 8. So this is our general setup. To actually do this, we just have to find the area under the curve here. So for this trapezoid, I've got a base of 2 plus a base of 6 over 2 times a height of 3. And for this triangle here, this is just 1/2 times a base of 2 times a height of 1. And it's going to be positive because we have absolute value working here. Now let's simplify this to get an answer choice. So right here we've got, let's see, 6 plus 2 over 2, that's going to be 4 times 3 is 12. Here we've just got 1. So 12 plus 1 gives us the value 13. So that's choice B. On this problem, we have a particle going on a straight line, and its velocity is given by this function here. we want the total distance traveled on the interval from 0 to 2. So total distance is just going to be the integral of the absolute value of velocity from the limits 0 to 2. Let's go ahead and plug this in the calculator. I'm going to start by putting this function in my y equals just to make it a little bit less unwieldy. And then I'll quit out of that and I'll do Math 9, my integral from 0 to 2. And I'm going to now do absolute value of y1, so alpha trace y1, and I'll do dx here. And according to the calculator, this is going to come out to approximately, let's see here, it's thinking, 2.261. So that's choice D. On this problem, we're given a particle moving on the x-axis whose velocity is given by this function here. This is a calculator problem, so I'm going to go ahead and enter this in my y equals right away. There we go. I know I'm going to need this later, so let me keep going on the problem now. So at time 4, is the particle speeding up or slowing down? Well, we need to compare the velocity and the acceleration of our particle at time 4. So let's start by finding the velocity at time 4. And they gave us a v function here, so we can just do v of 4 on the calculator. So here's my velocity function. Let me quit out of here and do alpha trace y1 of 4. So we're just directly plugging 4 into our function. Comes out to about 2.979. And that's positive. That's really what we care about here. Next, we need the acceleration at time 4. Now that's going to be v prime of 4, and you have to spell this out. You can't just kind of start talking about a of 4 and expect people to know what you mean. So let's see what this is on the calculator. Now, I don't actually have to algebraically take this derivative. I can just plug it in at a single point to the derivative on the calculator because it's just one spot. So let me do math 8, d over dx, and I'll do alpha trace, put my y1 in that derivative function. And again, I'm doing this at time 4, so x equals 4 there. That comes out to negative 1.164, which significantly is negative. So I notice here that v of 4 and a of 4 have opposite signs. They're working against each other. So that means our particle is slowing down at time 4. For this next part of the problem, we want to find all times in the interval from 0 to 3 when the particle is changing directions, and then justify the answer. Okay, so we're basically asking where velocity is changing from positive to negative or negative to positive. So we're going to start by setting velocity equal to 0 to find those critical values, and we're going to find that on the calculator. So recall on the calculator, I stored my velocity function is y1. I'm going to go to window now, and they said, let's see, interval from 0 to 3. So let me go from 0 to 3 with my x range, and then let me do zoom fit, zoom 0, so I can get a good picture of what's going on with my velocity function. And we see that we're only actually going to be crossing the x-axis in one spot, right here close to 3. To find the exact spot, though, let me do second trace and 0. And let's see, let's click a little bit to the right, or the left rather, of that x-intercept, and a little bit to the right. Click one more time for good measure. And we end up with 2.707 and some change. So that's the time where our particle is crossing the x-axis. Now this by itself is not enough. You have to show that velocity changes sign at t equals 2.707. The sign change is really the most significant part of this. Because we change sign for velocity, that means that our particle changes direction at that time. For this part of the problem, we just want the position of our particle at time 0. Now for this, we have to look back in the problem stem where it says that the particle's at position x equals 2 at time 4. So I'm going to use the FTC on this one. I'm going to say that x of 0 equals x of 2, or x of 4 rather, which is just 2, plus the integral from 4 to 0 of v of t. Notice that I'm going from 4 to 0, not 0 to 4. My starting value is 4, my ending value is 0 here. Now the rest of this is just plugging it in the calculator. So I've got 2 plus integral from 4 to 0 of, and let's see, I did y1 was my velocity function on the calculator. So let me just recall that, and we have dx, and that all comes out to negative 3.815. For this part of the problem, we want the total distance the particle travels from time 0 to 3. So for this, we need the integral of the absolute value of velocity from 0 to 3. Let me plug this in the calculator. So I've got my integral from 0 to 3, and let me do absolute value now of alpha trace y1 dx, and let's see what our calculator comes up with for this. So it's going to have to think a little bit because we have a sine function, so this thing's bouncing all over the place. We've got 5.301, and in calculator we trust, it's a wrap.